Have you ever wondered how your computer actually works? I mean, really deep down. Because underneath all the apps and photos and everything else, it's all powered by this secret language. Well, today we're going to decode that language and find out how our entire digital world is built on just two simple numbers. So on one side, you've got us, right? We live in this world of nuance and color and texture. And on the other side, you have the computer. It lives in a world of pure, cold logic and absolute values. You know, we see a photo of a cat, but the computer, it just sees code. And that's the big question, isn't it? We communicate with words and feelings and ideas. Computers speak in, well, something else entirely. So how in the world do these two completely different worlds talk to each other so perfectly? To make all this work, we have to bridge what you could call a communication gap. We need a translator, right? A system that can take our instructions and turn them into something a machine can actually understand and, well, do something with. And this really is the fundamental barrier. It's stated right here, crystal clear. Computers are unable to understand the data and instruction provided in human languages. It doesn't matter how smart they get, you can't just talk to them like you would a person. We have to have that translator. So, to understand the computer's language, it actually helps to take a quick look at our own first. You know, the language of our numbers, the one we use for everything from counting our change to doing super complex math. It's all built on a very specific foundation. It all comes down to these 10 symbols. Just these 10. I mean, think about it. Your phone number, your bank account balance, the number of likes on your last post, it's all just a clever combination of these simple digits. So this is what we call the decimal system, or a base 10 system. Why? Well, simply because it has 10 unique symbols. It's the numerical alphabet we've all been using since we were kids. Now, just hold on to that idea of a base. Because in computer's world, it's dramatically simpler. It doesn't have 10 symbols to work with. Nope. It only has 2. And this is the foundation of a completely different kind of language. So here it is, side by side. Our system, decimal, is base 10 because it uses 10 symbols. The computer system, which we call binary, is base 2. Its entire language is built from just 0 and 1. That's it. And each one of these binary digits has its own name, a bit. And a bit is the absolute smallest piece of information a computer can handle. You can think of it as the atom of the digital universe. You know, the easiest way to think about a bit is like a simple light switch. It only has 2 possible states. It can be off, which the computer sees as a 0, or it can be on, which it sees as a 1. And this is why computers use binary. At their core, they're just these massive collections of electronic switches. Representing 2 states is super easy. Is electricity flowing? That's on, a 1. Is it not flowing? That's off, a 0. It's simple, it's reliable, and it's just perfect for how hardware is built. Okay, so if we use base 10 and computers use base 2, how do we actually translate between them? Well, it's actually a surprisingly simple process. It's all about division. All right, let's try it. We'll take a number we all understand. Let's say 13. The process is simple. You just keep dividing that number by 2. After each division, you just jot down the remainder, which, of course, is only going to be a 1 or a 0. And when you can't divide it anymore, you just read those remainders you wrote down, but you start from the bottom and go up. And voila! Our number 13 becomes 1110 in binary. We've just translated from human to computer. That simple sequence of on and off signals is what lets a physical machine process a logical idea like a number. And guess what? This translation works perfectly both ways. See, each spot in a binary number has a specific value. If you go from right to left, the first spot is worth 1, the next is 2, then 4, then 8, and so on. They're all powers of 2. So the computer takes a number like 1101 and just adds up the value for each one. In this case, that's an 8 plus a 4 plus a 1. Add them together, and what do you get? 13. A perfect translation right back to our language. Okay, so translating numbers, that kind of makes sense. But what about, well, everything else? Photos, music, the words in an email? This is where it gets really, really cool. Because to a computer, it's all just numbers. So we look at this and we see a beautiful park scene. We recognize trees, colors, light, shadow. Our brain just processes all of that instantly. But the computer, it only sees this, a massive, relentless stream of ones and zeros. Each little bit represents a tiny piece of that image,
like the specific color of a single pixel or how bright it is. It's the exact same picture, just spoken in a different language.
And this idea applies to absolutely everything. The letter A on your keyboard, to the computer, that's just the binary code 01000001. A single note in your favorite song? Yep, that's another binary code. The number 9, a different code. Every single piece of information you interact with on a computer is at the end of the day just a unique sequence of on and off signals. So every key you press, every file you save, every single pixel on your screen, it all gets converted into these long strings of bits. And it's the job of the central processing unit, the CPU, the brain of the computer, to read millions of these ones and zeros every single second, figure out the instructions they represent, and then translate the results back into something we can actually see and hear.
You know, when you take a step back and think about it, the implications are just staggering. Our entire digital world, every website, every video game, every scientific breakthrough that uses a computer is all built on a language that only has 2 words, 0 and 1.
And that's really the ultimate takeaway here. From the very moment you click your mouse to the moment an image pops up on your screen, absolutely everything happening inside that machine is being carried out using digits 0s and 1s.
Just let that sink in for a second. Everything you're watching right now, every video you've ever streamed, every game you've ever played, is just an incredibly long list of on and off switches. Isn't that wild? And it makes you wonder, right? With such a simple language, what are the limits to what we can build? What's going to come next?